Introduction. The cloud is calling, and it pays well. You've heard the stories. You've seen the headlines. You know that the world of cloud computing is a booming, high-stakes frontier where fortunes are being made and the very fabric of our digital world is being built. You see the job postings with their eye-watering salaries and know that a career in the cloud is a ticket to a more stable, more lucrative, and more exciting future. But then a familiar, sinking feeling sets in. You look at the jargon: AWS, EC2, S3, VPC, Lambda, and it feels like an impenetrable wall of cryptic, technical code. It seems like a world reserved for computer science geniuses, for people who were born with a keyboard in their hands. You have the ambition, but you don't have the degree. You have the desire, but you don't have a map. You're standing at the bottom of a mountain, looking up with no idea where the path begins. This is the moment that stops 99% of aspiring tech professionals in their tracks. They see the mountain, they feel the overwhelm, and they turn back. This book is the map for the other 1%. Welcome to From Zero to Cloud Certified. This is not a dense, theoretical textbook. This is a practical, step-by-step roadmap designed for one purpose: to take you from a complete beginner to a hireable, certified cloud professional in the most direct and efficient way possible. We are going to treat your career transition not as a hopeful gamble, but as an engineering project. First, we will deconstruct the intimidating world of cloud computing, breaking it down into its simple, core components and giving you the foundational architect's mindset. Next, we will guide you through the training protocol, showing you exactly which Amazon Web Services, AWS, you need to master and how to do it using a free, hands-on account. Most importantly, we will move beyond theory and into the real world. We will walk you, step by step, through the process of building a single, high-impact portfolio project, a tangible, working application that will become the undeniable proof of your skills. Finally, we will show you how to leverage that project to conquer the job market, from passing your certification exam to acing the technical interview and landing your first six-figure offer. The cloud is not a world reserved for geniuses. It is a system, and any system can be learned. It's time to stop looking at the mountain and start climbing. The path begins now. Part 1. The Foundation, Deconstructing the Cloud. Case File 01. The Architect's Mindset. You are not a coder. You are a problem solver. Before you learn your first technical term, before you open your first console, we must install a new, more powerful mental operating system. The single greatest misconception that paralyzes beginners is the belief that a career in the cloud is about being a brilliant coder. They imagine a solitary genius, fluent in a dozen programming languages, who can write thousands of lines of flawless, complex code from memory. This image is a myth, and it is the primary source of imposter syndrome for aspiring tech professionals. You are not here to become a coder. You are here to become an architect. This is a critical distinction. A coder is a specialist who is an expert in writing instructions in a specific language. An architect is a systems thinker who is an expert in solving problems. The architect's primary skill is not writing code. It is understanding a problem, deconstructing it into its component parts, and then selecting and assembling the right pre-built tools to create an elegant and efficient solution. This is the entire philosophy of modern cloud computing. Companies like Amazon Web Services, AWS, have already done the impossibly complex coding for you. They have built an incredible set of powerful, prefabricated digital Lego bricks. There's a brick for storing files, S3, a brick for running a virtual computer, EC2, a brick for managing a database, RDS, and hundreds of others. The job of a cloud engineer is not to invent a new kind of plastic. Their job is to know the Lego catalog inside and out. Their value is in their ability to look at a business problem. We need a website that can handle 1 million visitors without crashing and say, to build that, we will need 2 of the blue bricks for the red bricks and 1 of the yellow bricks, and we will connect them in this specific way. This is the architect's mindset, and it should be a source of immense relief and empowerment. You do not need to be a math genius. You do not need a computer science degree. You do not need to memorize thousands of lines of code. What you do need is a relentless curiosity about how systems work, a passion for solving puzzles, and the discipline to learn the catalog of tools available to you. Your primary skill will be your ability to look at a complex system and draw a simple diagram on a whiteboard. The code is often the last, and sometimes the easiest, part of the process. Throughout this roadmap, you must constantly remind yourself of this core identity. When you feel overwhelmed by a technical detail, zoom out. Ask yourself, what problem does this tool solve? When you feel the pull of imposter syndrome, remind yourself, I am not a coder. I am a problem solver. I am an architect. This mindset is the foundation upon which your entire six-figure career will be built. Case File 02. What is the cloud? A jargon-free blueprint of AWS, Azure, and GCP. Let's begin by demystifying the single most overused and poorly understood term in modern technology, the cloud. When you strip away all the marketing jargon and technical complexity, the cloud is a remarkably simple concept. For decades, if a company wanted to run a website or a software application, they had to own a physical server. This was a powerful, expensive, room-sized computer that they kept in a closet or a dedicated data center. They were responsible for buying it, powering it, cooling it, securing it, and fixing it when it broke. This was incredibly expensive, inefficient, and difficult to scale. If their website suddenly became popular, they couldn't just add more server. They had to go through a long, expensive process of buying and installing new hardware. The cloud is the solution to this problem. A few massive technology companies, namely Amazon with Amazon Web Services or AWS, Microsoft with Azure, and Google with Google Cloud Platform or GCP, decided to build colossal, planet-spanning networks of these data centers themselves. They then began renting out access to their computers over the internet. That's it. At its core, the cloud is simply someone else's computer. Instead of buying your own server, you can now rent a virtual one from Amazon with a few clicks of your mouse, and you only pay for what you use by the second. Need more power for a big product launch? You can rent 1,000 servers for an hour and then turn them off when you're done. This is the revolutionary concept of utility computing. It's like having a power plant in your basement versus just plugging into the electrical grid. The cloud is the global electrical grid for computing power. The big three, AWS, Azure, and GCP. While there are many cloud providers, the market is dominated by three major players. As an architect, you need to know who they are. 1. Amazon Web Services, AWS, the undisputed market leader. AWS was the pioneer in this space, launching in 2006. They have the largest market share, the most extensive catalog of services, and the biggest community of users. For this reason, AWS is the primary focus of this roadmap. Mastering AWS makes you instantly marketable to the largest number of companies. 2. Microsoft Azure, the powerful number 2. Microsoft was a later entrant, but has leveraged its massive, existing relationships with large corporations to become a dominant force in the enterprise space. Many large, traditional companies that have been using Microsoft product for decades choose Azure for their cloud needs. 3. Google Cloud Platform, GCP, the innovative number 3. Google is a powerhouse in data analytics, machine learning, and containerization, advanced cloud technologies. Startups and tech-forward companies that are heavily invested in data often gravitate toward GCP for its cutting-edge tools. The architect's choice, why we start with AWS. While the core concepts of cloud computing are transferable between these three platforms, your goal is to become job-ready in the most efficient way possible. Therefore, we will focus exclusively on AWS for this roadmap. The logic is simple. Maximum opportunity. More companies use AWS than any other platform. Mastering it opens the most job opportunities. Standardization. AWS set the standard. The language and concepts you learn in AWS are the lingua franca of the cloud. An architect who knows AWS can learn the specifics of Azure or GCP relatively easily. Best-in-class training. AWS provides the most extensive and accessible free training resources, which we will leverage heavily in this playbook. You are now armed with a clear, jargon-free understanding of the landscape. The cloud is not a mysterious, intangible fog. It is a tangible service provided by a few key players, and you are about to become an expert in the services offered by the market leader. Case File 03, the six-figure skill set, the core competencies that companies actually hire for. A common mistake for beginners is to get lost in the overwhelming catalog of cloud services. AWS alone offers over 200 distinct services, from satellite ground stations to quantum computing. The novice, in a fit of perfectionism, believes they must learn all of them. This is the path to burnout and failure. A senior architect understands that the 80-20 principle applies here with immense force. About 20% of the available services are used to solve 80% of the real-world business problems. A company is not hiring you because you have memorized the entire AWS encyclopedia. They are hiring you to solve their problems. And their problems, for the most part, revolve around a handful of core competencies. Your mission is to ignore the noise and focus with surgical precision on mastering the handful of skills that directly map to these core business needs. This is the true six-figure skill set. The four core competencies of a cloud professional infrastructure and compute. The business problem. We need a reliable, scalable, and cost-effective way to run our software. Your skill set. You must be able to provision and manage the virtual servers, EC2, and serverless functions, Lambda, that are the fundamental building blocks of any application. You must understand how to make them run efficiently and how to scale them up or down based on traffic. The analogy. You are the master of the engine room. Storage and databases. The business problem. We have a massive amount of data, from user files to application logs, and we need a secure, durable, and accessible place to store it. Your skill set. You must be able to choose the right storage solution for the right type of data. This means mastering file storage, S3, server storage, EBS, and the two main types of databases. Relational, RDS, for structured data, and NoSQL, DynamoDB, for unstructured data. The analogy. You're the master of the library and archives. Networking and security. The business problem. We need all of our cloud components to be able to talk to each other securely, and we need to protect our entire system from unauthorized access and external threats. Your skill set. This is the most critical and often the most intimidating competency. You must be able to design a secure private network in the cloud, VPC. Most importantly, you must master the principles of identity and access management, IAM, ensuring that only the right people and services have permission to access the right resources. The analogy. You're the master of the fortress walls and the keys to the kingdom. Automation and infrastructure as code. The business problem. Doing all of this manually is slow, prone to human error, and difficult to replicate. We need a way to build and manage our cloud environment in an automated, repeatable, and documented way. Your skill set. This is the skill that separates a junior administrator from a senior architect. You must learn the principles of infrastructure as code, IAC. This means using a tool like AWS CloudFormation or Terraform to define your entire cloud setup in a text file, a blueprint. Instead of clicking around in a console, you run a script that builds your entire system automatically. The analogy, you're the master of the factory assembly line, able to produce a perfect, identical car every single time. That's it. These four areas are the pillars of a successful cloud career. As you proceed through this roadmap, you will see that our training protocol is relentlessly focused on building your practical, hands-on skills in these four domains. By mastering this core set, you'll be building the exact skill set that companies are willing to pay a premium for. Case File 04, the certification roadmap. Choosing your path from cloud practitioner to solutions architect in the world of self-taught tech professionals. A certification is not just a piece of paper. It is a powerful signal to the market. It is an industry-recognized, third-party validation that you have a foundational level of knowledge in a specific domain. For someone without a traditional computer science degree, a respected certification is the single most effective tool for getting your resume past the initial screening and into the hands of a hiring manager. It is your official entry ticket to the game. AWS offers a vast landscape of certifications, from foundational to highly specialized. The novice is often paralyzed by choice, unsure of where to start or which path will provide the best return on their investment of time and effort. The architect, however, sees a clear, logical progression. Your goal is not to collect as many certifications as possible, but to acquire the right certifications in the right order to maximize your employability. The Zero to Ready certification path for a self-taught professional aiming for a cloud engineer or solutions architect role. There's a proven two-step certification path that provides the optimal balance of foundational knowledge and high-value credentials. Step 1. The Foundational Credential AWS Certified Cloud Practitioner. Who it's for? This is the entry point. It is designed for anyone, technical or non-technical, who wants to understand the fundamental concepts of the AWS cloud. What it covers. It does not test deep, hands-on skills. It tests your understanding of the what and the why of the cloud. What are the core benefits of cloud computing? What are the main AWS services, and what business problems do they solve? What are the basics of AWS pricing and billing? The strategic value. While this certification alone will not get you a high-level engineering job, it is a crucial first step that IT builds your vocabulary. It forces you to learn the lingua franca of the cloud, which is essential for understanding more advanced concepts and for sounding credible in an interview. It de-risks the process. It's a relatively easy exam that gives you a quick win, building your confidence and proving to yourself that you can succeed in this new field. It's a check-the-box credential. For many non-technical or entry-level roles, this is the minimum requirement that recruiters look for. Step 2. The Job-Ready Credential AWS Certified Solutions Architect Associate. Who it's for. This is the gold standard, the most recognized and sought-after cloud certification in the world. It is designed for individuals who will be architecting and deploying systems on AWS. What it covers. This is a serious, technical exam. It moves beyond the what and tests the how. It presents you with realistic business scenarios and asks you to design a solution that is secure, cost-effective, high-performing, and resilient using the Core AWS Services. This exam directly tests the 4 core competencies we identified in the previous chapter. The strategic value. This is the certification that unlocks 6-figure opportunities that IT proves your competence. Passing this exam is a rigorous, undeniable proof that you have the practical, architectural knowledge to build real-world solutions on AWS. It is a keyword for recruiters. AWS Certified Solutions Architect is one of the highest volume search terms used by tech recruiters on LinkedIn and other job platforms. Having this on your profile turns you into a magnet for opportunities. It provides the perfect study framework. The curriculum for this certification is, in essence, a perfectly structured roadmap for learning the most important, commercially valuable AWS services. By studying for this exam, you're undertaking the most efficient learning plan possible. Your roadmap's primary objective. This Zero to Ready roadmap is architected around a single primary objective: to give you the knowledge and, more importantly, the hands-on project experience required to pass the AWS Certified Solutions Architect Associate exam. The Cloud Practitioner is a valuable milestone along the way, but the Solutions Architect certification is our ultimate destination. It is the key that will open the door to your new career. Part 2. The Training Protocol. Mastering the Core Services. Case File 05. The Sandbox Environment. Setting up your free AWS account without financial risk. The single biggest fear that paralyzes a new cloud learner is the fear of an unexpected, catastrophic bill. You've heard the horror stories. Someone leaves a powerful virtual server running by accident and wakes up to a credit card charge for thousands of dollars. This fear prevents the most important part of the learning process: hands-on experimentation. You cannot learn to be an architect by only reading the blueprints. You must be able to pick up the digital Lego bricks and build things. Therefore, our first and most critical step in the training protocol is to construct a sandbox environment. A sandbox is an isolated, controlled space where you can build, experiment, and even make mistakes without any risk of a surprise bill. AWS provides a powerful tool for this called the AWS Free Tier. Your mission is to set up your account and then immediately architect a set of financial guardrails to make it virtually impossible to accidentally overspend. Step 1. Create your AWS account. Action. Go to the AWS homepage and sign up for a new account. You will need a valid email address and a credit card. Note on the credit card. The credit card is required for identity verification. You will not be charged as long as you stay within the free tier limits. This is a non-negotiable step. Choose the basic support plan. This is the free option. Step 2. The security mandate. Do this immediately. When you first create your account, you are logged in as the root user. This user has godlike permissions to do anything in the account. For security reasons, you should never use the root user for your day-to-day work. Your first action is to create a separate, limited user for yourself. Action. Go to the IAM, Identity and Access Management service. Action. Create a new user for yourself, e.g., Ron Gardinski admin. Action. Grant this user administrator access. Action. Log out of the root user account and log back in as your new IAM user. Store your root user credentials in a secure password manager and do not use them again unless absolutely necessary. Step 3. Architecting your financial guardrails. This is the most critical part of creating your sandbox. We will now set up a system that automatically alerts you if you are about to incur a charge. Action. Go to the AWS budget service. Action. Click Create a budget. Action. Choose the cost budget option. The zero spend budget. Set the budget period to monthly. Set the budget amount to a fixed $1. The alert threshold. This is the key. You will now set up an alert. Set the alert to trigger when the actual cost exceeds 100% of your budgeted amount, i.e., when your spending exceeds $1. Enter your email address to receive the alert. Action. Create the budget. The result. Your bulletproof sandbox. You have now created a powerful financial safety net. The AWS free tier gives you a generous amount of resources to use every month for free. In the unlikely event that you accidentally use a service or an amount of a service that is not covered by the free tier, your spending will exceed the $1 budget you created. The moment this happens, AWS will automatically send you an email alert. This system transforms your fear of a surprise bill into a simple, manageable notification. You're no longer flying blind. You have an early warning system in place. With this sandbox environment secured, you are now free to experiment, to build, and to learn with confidence, which is the true purpose of this training protocol. Case File 06, Core Compute, EC2 and Lambda, the brains of the cloud. We begin our training with the most fundamental component of the cloud, compute. Compute is the thinking part of any application. It is the raw processing power that runs the code, performs the calculations, and executes the logic. As an architect, your primary job is to choose the right type of brain for the right task. AWS offers a vast array of compute services, but for 80% of real-world problems, you only need to master two: EC2 and Lambda. EC2, Elastic Compute Cloud, your virtual server. The concept: EC2 is the workhorse of the AWS cloud. It is the digital equivalent of the physical server that used to sit in a company's closet. An EC2 instance is simply a virtual computer that you rent from Amazon. You can choose its operating system, Linux or Windows, its processing power, CPU, its memory, RAM, and its storage. You have full control over it, just like a real computer. You can log into it, install software on it, and run your applications. The use case: you use EC2 when you need a persistent, long-running computer to host a traditional application, like a website, a backend API, or a database that you manage yourself. It is the go-to choice for lifting and shifting existing applications into the cloud. The key skill: your job as an architect is to choose the right size of EC2 instance for the job. Choosing an instance that is too large is a waste of money. Choosing one that is too small will cause your application to crash. You must also learn how to use auto scaling groups, a powerful feature that automatically adds or removes EC2 instances based on traffic, ensuring your application is both cost-effective and highly available. Your first drill: Your first hands-on task in your sandbox will be to launch a small, free tier-eligible EC2 instance. You will then learn how to connect to it securely using SSH, a standard command line tool, and install a simple web server on it. This single exercise will teach you the fundamentals of virtual servers. Lambda, the serverless function. The concept. Lambda is the revolutionary evolution of compute. With EC2, you are renting an entire server and you pay for it by the hour, even if it's just sitting there waiting for something to do. With Lambda, you're not renting a server at all. You simply provide AWS with a small, self-contained piece of code, a function. AWS keeps that function ready, and it only runs it when it is triggered by a specific event. The use case. Lambda is used for small, event-driven tasks. A common example is an image processing function. When a user uploads a new photo to your application storage, the event, a Lambda function, can be automatically triggered to resize that photo into a thumbnail. You pay only for the few milliseconds that the code is actually running. This is the concept of serverless computing. You never have to think about or manage the underlying server. The key skill, the architectural mindset for Lambda, is completely different. You must learn to deconstruct a large application into a series of small, independent functions that can be triggered by events. This is a more modern, efficient, and often dramatically cheaper way to build applications. Your first drill, your second hands-on task, will be to write a very simple hello world function in a language like Python. You will then configure it in the Lambda console and learn how to trigger it manually. This will demonstrate the power of running code without provisioning any servers. Mastering the trade-offs between these two core compute services is a foundational skill for any cloud architect. EC2 gives you control and is ideal for traditional, long-running applications. Lambda gives you efficiency and is perfect for modern, event-driven tasks. Your ability to choose the right tool for the job is the mark of a competent and cost-conscious engineer. Case file 07, core storage, S3 and EBS, the filing cabinets of the cloud. Every application needs to store data. This data can be anything from the files that make up a website to user-uploaded images and videos to the operating system of your virtual server. Choosing the right storage solution is a critical architectural decision that impacts cost, performance, and durability. AWS provides a dizzying array of storage options, but your journey to mastery begins with two core services, S3 and EBS. S3, simple storage service, your infinite digital filing cabinet. The concept. S3 is one of the oldest and most important AWS services. It is object storage. The best analogy is a magical, infinitely large, and indestructible filing cabinet on the internet. You can store virtually any kind of file in it: images, videos, documents, backups, website code, and access it from anywhere in the world. Each file is an object stored in a bucket, which is like a folder. The key features, your selling points as an architect: durability. Data stored in S3 is replicated across multiple physical locations. It is designed for 99.999999999%, 11 nines, of durability, meaning that if you store 10,000 objects, you can expect to lose one of them roughly every 10 million years. It is one of the safest places to store data on the planet. Scalability. There's effectively no limit to the amount of data you can store in S3. Cost effectiveness. S3 is incredibly cheap, making it the default choice for a vast number of use cases. The use case. S3 is the go-to service for storing user-generated content, like profile pictures, hosting the files for a static website, as we will do in our portfolio project, storing application logs, and creating data backups. Your first drill. In your sandbox, you will create your first S3 bucket. You will then learn how to upload a simple file, like an image, to it, and, most importantly, how to configure its permissions so that it can be accessed publicly over the internet via a unique URL.ebs, elastic block store your virtual hard drive. The concept. If S3 is a giant, shared filing cabinet, EBS is a private, high-performance hard drive that you attach directly to a single EC2 instance. An EBS volume is the digital equivalent of a C drive on your personal computer. It is block storage, which means it is designed for the rapid reading and writing of data required to run an operating system and high-performance applications. The use case: every single EC2 instance you launch requires an EBS volume to store its operating system. You also use EBS when you need a fast, dedicated hard drive for an application running on your EC2 instance, such as a self-managed database that requires low-latency disk access. The key skill: the architectural decision here is about performance and cost. EBS offers different types of volumes, from cheaper, slower hard disk drives, HDD, to more expensive, lightning-fast solid-state drives, SSD. Your job is to analyze the performance needs of your application and choose the most cost-effective EBS volume type that meets those needs. You must also master the art of taking snapshots, backups of your EBS volumes that are stored cheaply and durably in S3. Your first drill: when you launched your first EC2 instance in the previous chapter, you already used EBS without even knowing it. AWS automatically created an EBS volume for the operating system. Your next drill will be to go to the EBS console, create a new, separate EBS volume, and then learn how to attach it to your running EC2 instance as a second hard drive. Understanding the fundamental difference between these two services is critical. S3 is for storing files in a durable, highly available, and cost-effective way. EBS is for providing a high-performance hard drive for a specific virtual server. Almost every well-architected application on AWS uses a combination of both. Case File 08, Core Networking, VPC, the plumbing of the cloud. You now understand how to create virtual computers, EC2, and virtual hard drives, EBS. But a computer that cannot communicate with other computers is useless. Networking is the plumbing of the cloud. It is the invisible infrastructure that allows your resources to talk to each other and to the outside world in a secure and organized way. For many beginners, networking is the most abstract and intimidating part of the cloud. It is governed by a set of strict, logical rules. A single misconfiguration in your networking setup can either leave your entire application vulnerable to attack or completely cut it off from the internet. Mastering the fundamentals of AWS networking is a non-negotiable skill that separates a hobbyist from a hireable professional. The core service for this is the VPC. VPC, Virtual Private Cloud, your personal, isolated slice of the cloud. The concept: the AWS cloud is a massive, public utility shared by millions of customers. A VPC is a service that allows you to carve out your own private, logically isolated section of that cloud. Think of it as building a secure, private office building on a piece of land you are renting in a giant city. You have complete control over who can come in and out, which rooms can talk to which other rooms, and how your building connects to the public road system, the internet. The core components, the architectural blueprint of VPC, is not a single thing. It is a collection of components that you, the architect, must assemble. Subnets. These are the individual rooms or floors within your office building. You will typically create public subnets for resources that need to be accessible from the internet, like your web servers, and private subnets for resources that should be kept secure and isolated, like your databases. Internet Gateway, IGW, this is the front door of your office building. It is a component that connects your VPC to the wider internet. Route tables. These are the hallway signs for your VPC. Each subnet has a route table that tells the network traffic where to go. A route table in a public subnet will have a rule that says, to get to the internet, go to the internet gateway. Security groups. These are the firewalls or security guards that stand in front of each individual resource, like an EC2 instance. A security group is a set of rules that defines what kind of traffic is allowed to come in and go out. For a web server, you would create a rule that says, allow incoming web traffic, HTTP/HTTPS, from anywhere on the internet. Network access control lists, NACLs, these are a second layer of security, acting like the security guards at the entrance to each subnet, the floor. They provide a broader, less granular level of traffic control. The key skill: Your job as an architect is to design a VPC that is both functional and secure. The most common and important architectural pattern is the public-private subnet design. You must learn how to place your web-facing EC2 instances in a public subnet so they can be reached by users, while placing your critical databases in a private subnet, completely isolated from the internet, to protect your sensitive data. The web servers in the public subnet are then given permission to talk to the databases in the private subnet. This is the bedrock of secure cloud architecture. Your first drill: your AWS account comes with a default VPC already configured for you. For your first drill, you will go into the VPC console and simply identify and map out the components of this default setup. Find the subnets. Look at the route tables. Examine the default security group. By deconstructing a working example, you will begin to understand how the pieces fit together before you build your own from scratch in our portfolio project. Networking can seem complex, but it is ruthlessly logical. By mastering this handful of core components and understanding the fundamental principle of the public-private security model, you will have acquired one of the most valuable and in-demand skills in the entire cloud computing industry. Case File 09, Core Databases, RDS, and DynamoDB, the memory of the cloud. Nearly every useful application, from a simple blog to a massive e-commerce platform, needs a database. A database is the application's memory. It is a structured, organized system for storing, retrieving, and managing information. It is where you store user profiles, product catalogs, blog posts, and game scores. As a cloud architect, choosing the right database for your application is a critical decision that will have a massive impact on its performance, scalability, and cost. AWS offers a purpose-built database for nearly every imaginable use case. However, as with all things in the cloud, the 80-20 rule applies. To be a job-ready professional, you must have a deep understanding of the two primary categories of databases and the flagship AWS service for each, RDS and Dynamo. DB.RDS, Relational Database Service, the organized spreadsheet. The concept: a relational database is the traditional workhorse of the application world. It organizes data into tables with predefined columns and rows, much like a highly structured and interconnected set of spreadsheets. It uses a language called SQL, structured query language, to interact with the data. The AWS service, RDS, in the past, setting up and managing a database was a complex, full-time job for a database administrator, DBA. RDS, Relational Database Service, is a managed service that automates all of this difficult work. You simply tell AWS what kind of database you want, e.g., MySQL, PostgreSQL, how powerful you want it to be, and AWS handles the rest: the patching, the backups, the security. The use case: RDS is the perfect choice for applications with structured, predictable data, such as an e-commerce store with tables for customers, products, and orders, a content management system, or most traditional business applications. Your first drill: in your sandbox, you will use RDS to launch a small, free tier-eligible MySQL database instance. You will learn how to configure its security group to only allow traffic from your web server security group, placing it in a private network space as per our security protocols. DynamoDB, the flexible, NoSQL database. The concept: as applications grew to internet scale, a new type of database emerged: NoSQL, which stands for Not Only SQL. A NoSQL database does not use the rigid table and column structure of a relational database. It is more like a giant, flexible digital filing cabinet where you can store data in a much more fluid format, often as key-value pairs or JSON documents. The AWS service, DynamoDB. DynamoDB is Amazon's flagship managed NoSQL database. Its superpowers are its incredible scalability and performance. It is designed to handle millions of requests per second with single-digit millisecond latency. Like Lambda, it is a serverless service. You never have to think about the underlying hardware. The use case: DynamoDB is the ideal choice for applications that need massive scale and high speed, such as mobile apps, gaming leaderboards, Internet of Things, IoT device data, and large-scale e-commerce shopping carts. It is perfect for data that is unstructured or where the access patterns are simple and well-defined. Your first drill. In the DynamoDB console, you will create your first table. You will learn the basics of defining a primary key, the main identifier for your data, and then practice adding, updating, and retrieving a few simple items of data. This will give you a feel for the fundamental difference in structure compared to a relational database. The RDS versus DynamoDB decision is one of the most common architectural questions a cloud engineer faces. There is no single best answer. The correct choice depends entirely on the specific needs of the application. RDS offers structure and flexible querying. DynamoDB offers massive scale and speed. Your job as an architect is to understand these trade-offs and to choose the right tool for the job. Our portfolio project will give you hands-on experience with both. Case File 10, the security mandate. I am the keys to the kingdom. We have saved the most important foundational topic for last. In the world of cloud computing, security is not an afterthought. It is the bedrock upon which everything else is built. A single security misconfiguration, a single key falling into the wrong hands, can lead to a catastrophic data breach, massive financial loss, and irreparable damage to a company's reputation. As a cloud architect, you are not just a builder, you are a guardian. Your deep, practical understanding of security principles is your single most valuable and marketable skill. The AWS ecosystem is a vast, interconnected kingdom of powerful services. The service that controls who or what is allowed to do what within this kingdom is called IAM, Identity and Access Management. Mastering IAM is not optional. It is the core of being a responsible and professional cloud engineer. IAM, the three core concepts. IAM is built on three simple but powerful concepts. Your job is to understand how they work together to create a secure environment. Users and groups. The concept: an IAM user is an individual person, like you, the engineer, who needs to interact with your AWS account. Instead of giving everyone the root password, a catastrophic security practice, you create a unique IAM user for each person. An IAM group is simply a collection of users. You can create a group called developers and another called finance, for example. The best practice: you never apply permissions directly to a user. You apply permissions to a group, and then you place users into that group. This makes managing permissions scalable and auditable. If a new developer joins the team, you simply add them to the developers group, and they instantly inherit all the necessary permissions. Policies. The concept: a policy is the most important concept in IAM. It is a formal, written document in a format called JSON that explicitly defines a set of permissions. A policy is a list of allow or deny statements for specific actions on specific AWS resources. An example policy: you could write a policy that says, allow members of the developers group to start and stop EC2 instances, but deny them the ability to delete the database. The principle of least privilege. This is the golden rule of all security. You should always grant the absolute minimum set of permissions the user or service needs to perform its job, and no more. Never grant blanket administrator access unless it is absolutely required. Roles. The concept. This is the most powerful and initially the most confusing part of IAM. A role is not for a person. It is for an AWS service. It is a way for one AWS service to get permission to interact with another AWS service without you ever having to store passwords or secret keys in your code. A critical use case. Imagine your EC2 web server needs to read a file from an S3 bucket. The wrong way to do this is to hard-code your secret access keys into the application on the server. The right way is to create an IAM role. This role has a policy attached to it that says allow access to read from S3 bucket X. You then attach this role to your EC2 instance. The EC2 instance can now assume that role and is temporarily granted the permissions it needs to talk to S3 securely and automatically. The architect's security mindset. Your default setting for everything in the cloud must be deny all. By default, nothing should be able to talk to anything else. Nothing should be accessible from the internet. Your job as an architect is to then poke small, specific, and intentional holes in that security wall to allow only the required traffic and permissions. This deny by default mindset is the foundation of a secure cloud environment. Your first drill, your first security drill, will be to go back into the IAM console. You will create a new IAM group called read-only users. You will then create a new policy that grants read-only access to S3. You will attach this policy to the group. Finally, you will create a new IAM user, place them in this group, and then log in as that new, limited user to confirm that you can see the files in your S3 bucket, but cannot delete them. This exercise will give you a tangible, hands-on understanding of the core IAM workflow. With this, your foundational training is complete. You now understand the core architectural components of the AWS cloud: compute, storage, networking, databases, and security. You have the vocabulary and the conceptual framework. Now, it is time to stop learning and start building. Case File 11, the job-ready project blueprint, architecting a real-world, resume-worthy application. You have now completed the theoretical portion of your training. If you stopped here, you would have enough knowledge to pass a certification exam, but you would be missing the single most important asset you need to get hire proof. A hiring manager for a cloud role does not just want to know that you can answer multiple choice questions. They want to see that you can build. They want tangible, undeniable evidence that you can take the digital Lego bricks of the AWS services and assemble them into a functional, secure, and well-designed application. Your portfolio project is that proof. It is the centerpiece of your resume, the main topic of your interviews, and the single most powerful asset for differentiating yourself from the hundreds of other certified but improving candidates. Many beginners make the mistake of following a simple, low-effort tutorial, building a toy project that doesn't demonstrate any real-world architectural thinking. Our project will be different. We're going to architect and build a cloud resume. This is a simple but powerful project that is specifically designed to showcase your mastery of the 4 core competencies of a cloud professional. The project blueprint is a serverless, dynamic, and secure web application. We're going to build a simple one-page website that will serve as your online resume. But this will not be just any website. Its underlying architecture will be a masterpiece of modern cloud design. The application's functionality is straightforward. The website will display your professional information, such as your name, your skills, and links to your professional profiles. It will also have a simple visitor counter and a contact form. The architectural brilliance of this project provides powerful talking points for an interview. The simple functionality of this website is a Trojan horse, allowing us to build a back-end system that demonstrates a sophisticated understanding of core AWS principles. Here is the architecture we will build. First, the website front end will be hosted in S3, demonstrating your knowledge of core storage. Second, the dynamic visitor counter will be powered by a Lambda function that communicates with a DynamoDB database, showcasing your mastery of core compute and core databases in a modern, serverless pattern. Third, the entire application will be deployed inside a custom-built VPC, demonstrating your mastery of core networking. Fourth, all interactions between the services will be governed by strict IAM roles, proving your mastery of core security. And fifth, in the final phase, you will define this entire architecture as code using CloudFormation, demonstrating your mastery of infrastructure as code. The next 4 chapters will be a step-by-step, hands-on guide to building this exact project. By the end of this section, you will not just have a piece of paper that says you are certified. You will have a working, professional-grade application running in the cloud. You will have your proof. Case File 12, Phase 1, the static website, deploying a simple, scalable site on S3. Our first construction phase is designed to achieve a quick, satisfying win while demonstrating a foundational cloud skill: hosting a static website. Your mission is to create an S3 bucket, configure it to act as a web server, and upload a simple resume file that can be accessed by anyone in the world. In Step 1, you will create your blueprint files on your local computer. You do not need to be a web developer for this. You will create a file named index.html which will be the main page of your site, and an error.html file. In step 2, you will architect the S3 bucket. Log into your AWS Sandbox account. In the S3 console, you will create a new bucket with a globally unique name. The key security step is to uncheck the box that says Block all public access and acknowledge the warning, then create the bucket. In step 3, you will configure the bucket for website hosting. Go into your new bucket, find the static website hosting section in the Properties tab, and enable it. Set your index document to index.html and your error document to error.html. After saving, AWS will provide you with your public website URL. In step 4, you will set the permissions policy. This is required to give the public permission to actually read the files. In the Permissions tab, you will edit the bucket policy and paste in the standard JSON policy provided in the book, making sure to replace the placeholder with the exact name of your bucket. In step 5, you will deploy your files by going to the Objects tab and uploading the index.html and error.html files. Finally, in step 6, you will verify the deployment. Copy the website endpoint URL from the Properties tab and paste it into your web browser. You should now see your live resume website. Congratulations! You have just successfully deployed a globally available, infinitely scalable, and incredibly low-cost website using AWS S3. Case File 13. Phase 2, the Dynamic Application, integrating Lambda and DynamoDB. Our static website is functional, but it lacks dynamic data. We are now going to elevate our project by adding the visitor counter. Your mission is to create a DynamoDB table to store the count, a Lambda function to update it, and an API to allow your website to communicate with your function. First, you will architect the database in DynamoDB. In the console, create a new table named Cloud Resume Visitor Count. The primary key will be ID with a type of string. Once the table is created, you will add an item to it. Set the ID to visitor_count and add a number attribute called count with an initial value of 0. Next, you will architect the brain of the application with a Lambda function. In the Lambda console, create a new function from scratch named updateVisitorCount using a modern Python runtime. The crucial security step is the IAM role. You will choose to create a new role with basic Lambda permissions. After the function is created, you will navigate to the IAM console and attach the Amazon DynamoDB full access policy to this new role. Then, you will write the function code. Back in the Lambda console, you will paste the Python code from the book into the code editor and click Deploy. This code connects to your DynamoDB table and increments the count by 1. Finally, you will create the front door using API Gateway. Since your website cannot call Lambda directly, it needs a public endpoint. In the API Gateway console, you will build a new HTTP API. You will add an integration, selecting Lambda, and choosing your Update Visitor Count function. You will name the API Cloud Resume API and accept the defaults to create it. The system will then provide you with an invoke URL. This is the public address your website will use. With this in place, you have officially built a sophisticated, dynamic, and fully serverless web application. Case File 14, Phase 3, the bulletproof architecture, making your project secure, fault-tolerant, and highly available. You have built a working application. A junior developer would stop here, but you're an architect. A professional-grade application must be secure, resilient, and highly available. Your mission is to refactor your project to meet these high standards. First, the security overhaul. Your Lambda function is currently in a shared, less secure default environment. You will build your own fortress. In the VPC console, you will create a new custom VPC with public and private subnets across 2 different availability zones. You will then reconfigure your Lambda function to run inside these private subnets, isolating it from the public internet. Finally, you will refine your IAM policies, replacing the overly permissive manage policy with a custom, inline policy that grants only the specific permissions needed, adhering to the principle of least privilege. Next, the availability upgrade. A professional architect designs for failure. You will introduce CloudFront, a global content delivery network, to cache your content closer to your users. You will create a CloudFront distribution with your S3 bucket as the origin. Then, you will reverse our earlier step and re-enable block all public access on the S3 bucket itself. You will create an origin access identity, or OAI, in CloudFront and update your S3 bucket policy to only allow access from that OAI. Now, users access your site via the resilient CloudFront network, and your source files are completely private. This is a massive architectural upgrade. Finally, the cost optimization check. Your serverless architecture is already incredibly cost-effective. Your interview talking point is this: I chose a fully serverless architecture. As a result, the monthly cost to host this dynamic, globally available application is effectively zero under the AWS free tier. This demonstrates a deep, practical understanding of cloud financial management. By completing this phase, you have proven you can think like a senior cloud architect. Case File 15, documenting your work. The art of the professional README and architectural diagram. The final piece of your portfolio project is not code, it is communication. Your ability to clearly and concisely document your work is a critical skill that separates a junior tinkerer from a senior professional. Your mission is to create two key pieces of documentation: a professional README.md file and a clear architectural diagram. First, the code repository. All of your project's code must be stored in a GitHub repository. Creating a clean, well-organized repository is a non-negotiable sign of professionalism. Second, the professional README file. This is the front page of your repository and the first thing a hiring manager will look at. It must be clear and professional, containing the project title, a brief description, the architectural diagram, and a bulleted list of the key features and services used. Third, the architectural diagram. A picture is worth 1,000 lines of code. Using a free online tool like diagrams.net, you will create a simple, visual blueprint of your system using the official AWS architecture icons. Your diagram should visually represent the flow of a user's request from their browser through CloudFront to S3, and separately through API Gateway to Lambda and DynamoDB, all enclosed within a box labeled VPC. You will export this diagram as an image and add it to your README file. With your code in GitHub, your professional README, and your clear architectural diagram, you have completed the full life cycle of a professional engineering project. Case File 16, the Certification Assault Plan. How to study for and pass your AWS exam on the first try. You have now built a real-world, hands-on project. You are now perfectly positioned to conquer the final gatekeeper, the certification exam. You must now pivot from being a builder to being a test taker. This requires a specific, disciplined assault plan. This is an intensive, 4-week study protocol designed for maximum efficiency. Week 1 is the core curriculum. Your objective is to get a comprehensive, high-level overview of all topics on the exam. You will enroll in a single, high-quality, exam-focused video course and watch the entire course at 1.5x speed. The goal is to expose your brain to the material and identify your weak areas. Week 2 is the deep dive and hands-on reinforcement. You will rewatch the sections of the video course that cover your identified weak areas, this time at normal speed, following along in your own AWS Sandbox account. This active engagement is critical for converting theoretical knowledge into durable memory. Week 3 is the practice exam gauntlet. Answering these scenario-based questions is a separate skill from knowing the material. You will acquire a high-quality set of practice exams and take one full time practice exam every single day. After each exam, you will spend twice as much time reviewing the answers, understanding why the correct answer is correct, and, more importantly, why the other options are incorrect. Week 4 is the final polish and review. You will review your notes from the practice exams, focusing on concepts you consistently got wrong. You will also create a single one-page cheat sheet of the most important facts. The day before the exam, you will not cram. You will do a light review in the morning, and then you will stop. Your brain needs time to rest. Finally, you will schedule your exam. This structured plan transforms studying from a vague, stressful activity into a clear, manageable project, architecting a near-guaranteed path to passing on your first attempt. Case File 17, the cloud-optimized resume, translating your portfolio project into recruiter-ready language. You have the skills, the project, and the certification. But none of that matters if you cannot effectively communicate your value. Your resume has one job: to get you an interview. An architect's resume is an active sales pitch. It showcases what you achieved. Your cloud resume portfolio project is the single most powerful achievement you have, and it must be the star of the show. We will architect your resume with ruthless efficiency. Section 1 is the header with your name, contact info, and, critically, clickable links to your LinkedIn and GitHub profiles. Section 2 is the professional summary, a 2 to 3 sentence elevator pitch packed with keywords like AWS Certified Solutions Architect and serverless applications. Section 3 is for certifications, placed right near the top. Section 4 is for projects. This is the main event. You will showcase your cloud resume project using the language of achievement. Your project title should be a clickable link to the live website. Your bulleted achievements must be powerful, such as architected and deployed a fully serverless, dynamic website, leveraged S3 for hosting and CloudFront for global content delivery, implemented a dynamic visitor counter using API Gateway, Lambda, and DynamoDB, and design and configure secure VPC with public and private subnets. Section 5 is for technical skills, a keyword-optimized list of your competencies. Section 6 is for professional experience and education, where you will frame past roles to highlight transferable skills. This cloud-optimized resume is designed to get your foot in the door for the technical interview. Case File 18, the technical interview gauntlet, a playbook for whiteboard challenges and system design questions. Your resume worked. You have been invited to the technical interview. This is the moment where you prove what you can do. The technical interview is not a test of what you know, it is a test of how you think. The interviewer is evaluating your problem-solving process. Your mission now is to learn how to showcase that thinking process in a clear, structured way. You will use the 4-step whiteboard protocol. Step 1 is to clarify. Never start solving immediately. The initial question is often deliberately ambiguous. Ask clarifying questions to fully understand the constraints and requirements. Step 2 is to propose a simple, high-level design. Once you have the requirements, sketch out a version 1 solution on the whiteboard. As you draw, you must think out loud, narrating every decision. Step 3 is to discuss the trade-offs. This is the senior architect move. Critique your own design. Identify its potential weaknesses and discuss the trade-offs you have made. This demonstrates a deep, professional level of thinking. Step 4 is to iterate and deepen. The interviewer will now likely ask you to deepen your design based on the trade-offs you identified. You would then iterate on your design. By following this protocol, you transform the interview from a terrifying interrogation into a collaborative problem-solving session. Case File 19, landing the role. The final steps to securing your 6-figure offer. You have navigated the entire gauntlet. The final steps are about sealing the deal. First is the behavioral interview. This is often with a senior manager and is a test of your soft skills. Your playbook is to use the SAR storytelling framework, which stands for situation, action, result. Second is asking the right questions. At the end of the final interview, when they ask, "Do you have any questions for us?" your answer must be a confident yes. Ask about the team, the work, and what success in the role looks like in the first 6 months. Third is the offer and negotiation. When the offer comes, never accept on the spot. Express enthusiasm, then ask for 24 hours to review the details. Your counteroffer must be based on objective market data. Fourth is the thank you note. Within 24 hours of every interview, send a brief, personalized thank you email to each person you spoke with. By executing these final steps with architectural discipline, you're completing your transformation into a consummate professional. Conclusion: you are the architect of the cloud. You began this roadmap standing at the bottom of a mountain, looking up at an intimidating, jargon-filled peak. You held a desire, but you lacked a map. Today, you stand at the summit. The fortress is yours. You have systematically deconstructed that mountain, transforming it from an overwhelming obstacle into a series of manageable, conquerable steps. You have replaced the limiting belief of, "I'm not a tech person," with the empowering reality of the architect's mindset. You have learned the language of the cloud, moved beyond theory, and into the realm of the builder, architecting a real-world, resume-worthy application that serves as the undeniable proof of your competence. You have conquered the certification gauntlet and mastered the protocols for navigating the job hunting process. The path was not easy. It required focus, discipline, and courage. But the process was not magic. It was architecture. It was the result of following a clear, logical, and repeatable blueprint. This is a pattern you can now apply to anything. The Zero to Ready roadmap is not just a playbook for learning the cloud. It is a meta skill, a new operating system for your professional life. Your journey is just beginning. The six-figure role you are about to land is not the final destination. It is the new, higher altitude base camp from which you will launch your next expedition. You are no longer just a participant in the digital economy. You are one of its architects. You have the blueprint. You have the skills. You have the proof. Go build the future. Did this roadmap help you? Your journey is just beginning, but your feedback is crucial. If this book provided you with real-world value, the single best way to support this mission is to leave an honest review on Amazon. Your review helps other ambitious, self-taught pros find the tools they need to bypass the gatekeepers and build the career they